on the other side.
That's correct.
My goodness, everybody, just look at the hoodies that we have at the merch station. Get your very own hoodie right now, ladies and gentlemen. They are priced at $9.95. You don't need to just buy one. You can buy for your girlfriend, your boyfriend, your mom, your dad. You can buy for the whole family. It can be like a twinning jacket or a hoodie. It can be a family thing. Go ahead. It's just right there near the entrance. If you're not yet decided, maybe later on at the end of the program, go visit the merch store. So, I hope everybody also maximized your break, visiting all the booths and checking out all the services and the metaverse uses that they are showcasing right now. Anyway, everybody, we are now going to continue with the last stretch of our day one conference. So, ladies and gentlemen, please settle down and let us watch the next video. Everybody, our next speaker has a list of credentials so impressive that all you have to do is just sit down and listen. Today, software is more complex. Applications must be reliable, predictable, and easy to use to meet high expectations, right? And as developers, you have more responsibilities. To better understand your systems and create truly modern software, you need observability, and you need to dive deep into how this technology works under the hood. Without further ado, let us learn more about our next speaker.
Our speaker is an award-winning innovator, serial entrepreneur, and technologist, with over 17 years in software engineering, leading engineering of massive-scale projects, and developing products. He currently serves as a high-impact executive within Webb Fontaine R&D, leading engineering teams, and helping to improve processes and quality of services and products. He is also an adjunct lecturer at the American University of Armenia, an active member of open-source communities, and a presidential award winner. Let's all welcome Mr. Vahe Momjian.
Hello, everyone. Welcome to this wonderful event, a hybrid one. And I understand you are already tired after 6 hours of listening of this interesting content. So I'll try to keep you alive for the next 40 minutes or so. So today we're going to talk about observability. A little bit dive into how this can be achieved in Java applications, but I'll try to keep it more high level so that other people that are not very technical can also get more of this conversation talk. So I'm sure there are a lot of engineers here, and what we're going to do today is we're going to dive a little bit into what observability is and why do we need this, and then look into what's called and considered to be the 3 pillars of observability and how these are used, what are these. Then a little bit deep dive into how this is achieved in Java applications and how you can achieve yourself and what tools can you use. And then we'll talk about how you can build a culture and what that culture means for companies and how you can improve yourself. So let's try to answer a couple of questions. The first one is, can you identify which specific user is generating the most load? I'm sure there are a lot of engineers here who build complex systems. And it's very hard, when you have a complex system, it's very hard to even understand who's your most demanding customer in terms of resources. And then you need to know who's the second one, third one, or 100th one to be able to address these issues. Another question is, let's say some users complain about some slowness or timeouts happening. When you look on your graphs, you can see that 99 percentiles, 49 percentiles look good. How fast can you actually identify where your problems lie? Another question, which it's not really easy to answer, is how can you quickly, really quickly, within minutes, isolate any fault and a problem in your system to be able to solve it really quickly and understand where the problem lies. So let's look into why it's hard actually to do that in modern complex systems that consist of many moving parts. So our software is very complex, and it's getting more complex every next day because we're trying to build new systems. We're trying to build faster, more robust, more reliable systems with very low latency and high scalability. So as I've mentioned, applications must be reliable, predictable, and easy to maintain to meet high standards right now. And as developers, our responsibilities has grown as well. We're not just developing applications, but we are also responsible for these applications' maintenance and understanding what can go wrong before this goes wrong, because having customer impact is not a good thing. So to be able to do this, we need to understand how our systems work under the hood. And we need observability for our systems to be able to understand the technology under the hood, to be able to understand how our systems work, predict the problems that can happen, and solve this before they happen. So let's look into roots of what observability is. A mathematician, Rudolf Kalmer, published a work in 1960 defining what observability is. And he defined it in control theory. The observability is defined as a measure on how well internal states of the system can be inferred from the knowledge of external outputs. Let's kind of see what that means for software engineering. So for software engineering, observability is something very simple, like instrumentation that you build into your systems that collects the data. And then you need this other system which actually stores that data and gives ability to analyze it. And then the same system or other systems connected to that data sources help to provide insights and solve problems before they happen. And this provides insights for engineers, DevOps engineers, or site reliability engineers. So in other words, it helps us to get answers to the questions that you even didn't know that could happen. Let's say if you start seeing the problems before they happen, let's say degrading something in your system, and be able to react and be able to proactively react to that before this converts to customer impact. So, and then also observability provides actionable insights into your entire system, and not just parts of it, like this part is slower, that part is faster, or this part has problems. Sometimes problems are more complex than just one part of the system. So let's look on the left side. It's pretty simple architecture, layered architecture, where it was very easy to understand what's going wrong. It's either database or your backend, or something wrong in the front end, or in the middle, let's say it's a network or some hardware issue. But on the right side, the architecture is very complex by itself. It uses streaming data, it uses event-driven things, it has devices connected, it has dynamic build, dynamic scaling. So it's really, really hard to understand when something goes wrong. So that's why we need observability. So now, how this observability is connected with engineers, DevOps engineers, and site reliability engineers. It gives us opportunity and ability to react into things when things go wrong. There is a chaos engineering approach, which means that your systems are not reliable at all, and any part of the system can fail. So your systems can be ready to scale, or you need to be ready to react to problems before they occur. Or you use features, let's say feature flags, to deliver something to your different type of customers, same software, but with different features. You need to be able to understand how each feature affects your system when it's turned on or off for every single customer. Another thing is, with observability, you can progressively release patterns, understand your release patterns. Whenever you release something, you can explore your system, how your system behaves, and make decisions, make informed decisions, and detailed decisions about why this happened. And at the end of the day, nothing is reliable, 100% reliable. So when things happen, you have enough data to dive into incidents, analyze these, analyze the data that you have, and do a blameless postmortems to learn from this. So it also helps with continuous improvement. So let's look on what the 3 pillars of observability are considered to be. So the first one is the traces. So we will dive into each of these aspects, but let's look onto these very quickly. So what are the traces? Those are data that shows which line of code is failing or lagging in your system. And the next part is logs. Like our applications generate millions of lines of logs, and those are just texts that represent some event or just information that you can understand how your system behaves. And then also not to forget about metrics, which are just numbers describing some process, particular process, how this process behaves, and or activities measured over intervals of time. Let's say it can be very simple data like measurements from your sensors, or it can be very complex data where it shows the usage of CPU patterns over last couple of months, where you can find patterns of usage, where you can find your bottlenecks, and etc., or just reduce the resources you use. So let's talk about traces a little bit. So traces are relatively new aspect. And these show how each service invocation, like each service call, when it was called, how long it took for it to process, and then what is the next call behind it. It also allows us to see the parts of a single user call. So you can trace back how each single user uses your system and how it affects your system parts separately. So the traces can be also structured as trees of spans, which I'll show you now. So look on the top side. So it's the perceived time is the time that your customers are waiting for something to happen for them, for your system usage. So what actually happens is the processed time, perceived time is actually bigger because there is a network there and other parts. On the bottom, you can see the think time. This is the time that your system spends on processing the request and giving back the response, which the customers are waiting. So let's look on a little bit complex system now. It's a layered system where the perceived time is a little bit bigger because there are more think times involved. So the browser sends a request to the server, and then the server sends a request to the database. There are more think times. These orange think times are spans. And when you connect these spans with, let's say, some identifier and put this together, you will exactly understand for each customer request how much time and what exactly happened in your system. Now, let's look on the more complicated system, where you have now distributed things. Things are distributed over the network. Things are distributed over the even, let's say, continents. So every system can call other part of the system, and those can be distributed. And understanding these, when your systems are dynamically scaling up and down, is almost impossible if you don't have real observability and if you don't have traces. Well, what are traces? They're actually texts of events, something like this. It's just a JSON file describing an ID, and which is called a trace ID, and then a span ID, an ID for each span. But when you connect this together using tools available on the market, you clearly can see how your system behaves. So let's switch to the metrics now. As I've mentioned, like metrics are just numbers that are measured over the time. And examples of metrics would be, let's say, system metrics, the CPU, memory usage, disk speed, read speed, for example. An infrastructure metrics may be let's say, AWS CloudWatch metrics, which actually gives you a lot of insights on what's happening in your AWS infrastructure. A very simple web tracking script like Google Analytics, it's also metrics. And application metrics can be, let's say application performance monitors or error tracking metrics. Let's say how many error responses is given within provided specific time. And of course, you can build alerts based on that as well. So there are different typical 4 parts of metrics, which is the timestamp, name, value, and dimensions, which help you to build these metrics together, group them, and specifically analyze and understand what were the values of these metrics in the specific time period. And what is also important with metrics, they don't, the volume doesn't really scale with your request traffic because you measure it over the time. And also, of course, not to forget about logs, which are just text. Like there can be structured logs, there can be raw logs, there can be binary logs. And examples will be like, for example, for systems, there's a system log. Firewalls, network devices create a lot of logs. And there is also a lot of valuable information in it. In one of the startups I worked, we were analyzing the network logs, and we were predicting the age of the customer by network behavior. So these logs can be used in a variety of ways. There are application logs, which are logs that generated by application, by your frameworks you use. And also, there may be platform or server logs, which can be generated by your web servers. Now, how observability works under the hood. So let's look on the tools available that you can use out of box. Like, there are commercial solutions which you can buy, or you can use open source software. Like JMX is something that built in Java that you can export a lot of information from your Java applications. Micrometer is a framework you can use, a library, I would say, you can use to export metrics, or the OpenTelemetry, which is pretty new. And for Java applications, for example, OpenTelemetry is considered to be very mature. And you can integrate within minutes and export a lot of observability data. And now, there are other tools around OpenTelemetry which can gather this data and allow you to analyze this data. Now, these commercial solutions, some of them were considered to be application performance monitoring tools. But all these tools right now are more concentrating on observability itself. So they are connecting all their tools together so that you can see within every single point of time what was happening with your entire system, and not just part of it, let's say logs or metrics. So let's look a little bit closer into what happens when you run a Java application. So you have Java files, which is source code, and then you compile it, you get the binary files, like bytecode, that will later be interpreted and run. Now, these class files are loaded within Java virtual machine, and then in the virtual machine, those are loaded, verified, and then converted into native code, and then run. Now, what if we have possibility to intrude somewhere over there? You can see the red line there. Somewhere over there, when classes are loaded, and make changes into these. There are libraries that allow us to do that. These libraries we have libraries very low level where you can manipulate every and single method or field or anything in the class files. And then there are also high level, like aspect J, which allows you to write aspects and do something before, after, like log something when some specific type of methods are called. So using these systems, you can basically build Java agents which allow us to dive into application during the runtime, and extract useful information. Well, this is basically how all these tools work, including OpenTelemetry or any other tools. And you can build your own, a very simple way. Like, you can build a Java agent with 3 lines of code to load it, and something like 5 lines of code to do something with it. It's fairly easy, because the instrumentation allows it. Just one thing to mention here, it's called transformers, specifically in Java. But in other languages, other instrumentation exists to achieve the same result. So why it's called transformer? Because it allows you to load the initial class, initial object, initial class, and then modify it so that it behaves the way you want. Let's say just write a log when something happens, or extract telemetry data from the calls. Let's say measure the time your method is running, and et cetera, et cetera. There's a limitless amount of things you can do here. Now, having all these tools and possibilities, we need to build culture around this, because these don't just happen by themselves. Human nature is very conservative by itself. Many of us are used to doing something in specific way, and changing this is sometimes making us not comfortable. So let's look on some ways we can build culture around observability to be able to achieve observability at scale in the companies. So most probably, many of you know what is test-driven development. It's a way to develop applications, business logic, but first considering writing the tests. So how actually your system should behave, or your part of the system should behave. So you write tests, and then write an application the way to allow the test to pass. So you write a test, you let them fail, and then you write the application code, the business logic, and then you see that succeeding, which means like it actually meets your expectations and goals. Now, similar to test-driven development, you can build observability, you can do observability-driven development, which means like building observability as you build your system, and not just build the system and then think about how you introduce observability into your system, which is already quite late to do that. So the culture around it should be very welcoming and allowing to also try new things, because observability is, there is always a trade-off. Either you should buy tools or build at home. So look into your company talent and see if you have enough talent to build that observability. Or you can first buy things, build that, and then learn around it to have to build your own observability infrastructure. So generally, for us at Webb Fontaine, our engineers are responsible not just for developing the software, but also for operating it. And we actually have benefited quite a lot. I can tell you some numbers around, let's say, in the beginning of this year, from the beginning of this year, a number of incidents that we are recording every single month decreased 20 times. Which means that there is more time to do fun stuff, developing new things, developing new features. And of course, at the end of the day, this is beneficial for customer, which pays, which is beneficial for company, which pays more to the developers. So it's good for everyone. It even helps teams to deliver higher quality and maintainable software. Why? Because if you can observe the software, how software behaves, your system behaves early on, it's really easy for you to make decisions early on what you need to be fixed next, and concentrate on the weak points of your application or system. And at the end, also, observability can speed up your software delivery cycles. Why? Because with every single release, your software can behave differently, and you can very early on understand, even in your development environment, what could go wrong in the production, and avoid any impact that this can have on your customers. So building culture is not easy, but that's something that many companies do, and there is something that most of companies should do, which allows us to build habits on how things should be done in a good way. I don't know what happened. But I guess there was one more slide here, but I don't know what happened with that slide. That was the last slide, so I finished a little bit early. I don't want it to keep you for too long. So I would love to answer for all your questions that you have or might have.
Okay, thank you very much, Vahe. Again, as Sir mentioned, may we ask, there you go, may we ask for a round of applause first, and let's check if we have questions from our guests. Our apologies for the final slide, Vahe. Okay, here we go. I think we have. Thank you so much for sending in your questions. Question number 1. Is there a way to test observability to ensure that it has the necessary information to be useful?
Very interesting question in terms of there are observability maturity measures as well, which you can basically use to understand where are you with your observability measures, which is early on, you can assess where you are, and then you can understand what you need to improve on this. So yes, there is a way to test it. There are standards around it, and there's good practices around this, what your observability should look like. Don't forget that every single system is actually different. So even if you build the same product twice, you will build it differently the next day because you know what went wrong in the previous one. So it still is a little bit subjective. So you need to know how you want your system to behave because it's not only just technical metrics, but also there are business metrics, like how many transactions are we handling right now? How many business transactions, let's say checkouts, are we handling right now? And if number of checkouts go down very fast, that's a problem. Maybe technically everything is good, but in reality, it's a problem for business. So yes, there are ways to measure this.
All right, thank you very much for that answer. Do we have any more questions? Oh, this is question number 2. How can observability tools be able to detect or even minimize getting hacked in Java web apps?
Even more interesting question. In terms of security is the weakest point in many systems. And I don't know if you've heard, like, during the last couple of weeks, 5 Australian major companies were hacked and millions of users' data was stolen and published. And then people were blackmailed using that information. So it is possible to use observability to understand what could go wrong with your system. Although building security is another part of the system. Observability can definitely help you to do that, but you need to be very careful about security. There are security best practices. There are security scanners. And you need to use all of it together to be able to scan your system early on, starting from the libraries that you use in your application, ending up with the containers that you use in your applications, and then ending up the software that you use to orchestrate your containers, such as Kubernetes or OpenShift or other providers. And then ending up with your network. And then when you're done with your network, there are also a front-end part, let's say web application firewalls. So there is a lot of moving parts here with the security. Even simple web application can have multiple vulnerabilities. You need to build, again, culture around it to start looking at these problems early on in your systems, not to have problems later, because later it will be very hard to fix these. And when you have an impact, when you have a security problem, that's already a big problem.
Oh, perfect. Thank you very much. Next question. What are your thoughts on Kotlin replacing Java since they both run in JVM?
Well, Kotlin gets a lot of popularity, and it gets more popularity, most specifically after Google announced that they will be using Kotlin as their major language. So Kotlin will get more popular, and there is also Kotlin multi-platform, and so on and so forth. It's a beautiful language. I personally love it. So there are other languages as well running on JVM. Like there is, you can run Groovy, you can run Scala, and so on and so forth. With Kotlin, some problems are getting solved. But then if you look on the trends of Java itself, you can see that, like for example, a new things that are introduced lately, let's say virtual threads in Java. Those are trying to solve the problems that people found out early on and solved in Kotlin. Now it's solved for Java as well. So, and even like they introduced a lot of more new useful things. So it depends on the company, and it depends also how much legacy Java code do you have. And we, for example, have application which is written in Java, but tests are written in Kotlin. So I don't think a lot of things will change with Kotlin itself, unless you are looking into multi-platform things. But specifically for JVM, it's centralized kind of being developed, and JVM is there and will be there for a long time, which Java will still stay major for a couple of years. That's what I think. And then there may be other languages more popular, like Kotlin replacing Java applications, like it was with other languages as well.
Thank you very much for that answer. One more question. What is the best resource you can recommend for people, especially students, who want to dive in deeper in observability using Java? What is the biggest challenge in observability at the moment?
So there are a lot of resources already available. And I would personally recommend you looking to the observability, OpenTelemetry as a platform itself, because it's not just about Java, but it's generally a framework, a standard. It's becoming a standard for observability. It supports multiple backends to store the data that you collect. It have instrumentation for different runtimes, languages, and frameworks, operating systems, so you can gather data from everywhere. You can ingest data in different ways, and then you can visualize the data as well. So look into this OpenTelemetry, and you can start from there.
Thank you very much. There was about the challenges in observability.
And the challenges in observability are actually, the main challenge is still instrumentation. So there are tools provided by, there are commercial tools, which for bigger systems cost quite a lot. So it's really hard for smaller companies to look into this, to use these platforms. And then when you start building your own, which is, of course, there are a lot of open source applications you can use, like OpenTelemetry. If you use for Java specifically, it's very mature. So you'll be able to build something decent. But be careful, you have to take care of it as well after you build it. So it's not just out-of-box works. You need to have infrastructure behind it, network. So your observability stack can break as well. So you need to be aware of that from early on. And then there is a price for keeping that alive as well, and running, and performant as well. Because more data, you will need more resources to handle it.
Oh, wow. Thank you for that information. All right, next question. How much development effort do you need to implement the observability mechanism?
Well, let's consider with OpenTelemetry. If you are going to build it on your own, it's going to take a lot of time and resources, and you have to sometimes know what you're doing in terms of building observability stack is not a small task. You may need several types of infrastructure, let's say a storage, let's say Elastic, for example. And then you will need other systems for ingesting this, like collectors. And then also you need to gather metrics and logs, which can take a lot of space. So it's by itself, it's a separate organism running system that you need to take care of. So it's not really easy to get up and running, although for smaller scale, you can build a lot of stuff out of box. You can easily find Docker Compose, build script, and run it and get a pretty decent observability stack, which may work for you for the first 3 years, for example.
Thank you for that. Next question. Are application insights from Azure enough for the 3 pillars in observability on a microservice architecture?
It depends on what kind of applications are we talking about. So if your application is cloud native, built on Azure services provided by Azure, most probably it will be easier for you to extract a lot of observability data and connect it together using tools that are provided by Microsoft, and they're doing also lately quite amazing job on introducing new tools for DevOps to use to automate things and made it faster. So for Azure Stack, it may be easier if you are native. But the problem is the same if you build your application and running for example, on Kubernetes on using containers. So if you are building your application and you are trying to stay cloud agnostic, it will be much harder for you to get the observability there.
Okay, next question. How can you be sure that observability is accurate?
So to make sure your observability data is accurate, you need to take a look on it very thoroughly. So the first time you have a problem in your test system or development system or let's say any other non-production system, for example, we'll speak about production as well. So for these systems, as soon as you see a problem, performance issue, compare the data of compare your observability data with reality. And you will pretty easily and quickly see that if you can relate your problems with issues that people using your systems have, then most probably your observability data is correct. But there is other way you can look around it, which is observability will help you to predict that these problems will happen if you scale your system and so on. So look on your observability, try to find problems, and then validate that this problem actually exists, which usually is.
There's your answer. Thank you so much. Next question. Do you use the DORA metrics internally?
So internally, we do have some legacy systems, but we heavily invest in redesigning our application from scratch with newer technologies. We do that every single day, and we try to also improve our application observability as we start from scratch, building it from scratch. So yes and no. For some systems, it's not there because those are old. We don't want also to invest in this. But for the others, of course, we try to build everything the right way, so that it's easier for us to scale as well later.
All right. Our next question is, what is the cost implication of observability, especially in the short term for the business?
Well, in terms of costs, we can consider 2 types of costs. The first cost will be the development cost and learning curve. So that's one part of it. And then the second part of it would be also the cost on your application, because the more metrics you collect, the more dynamic things you do, the slower your application eventually will become. So you need to be careful on not introducing too many things at the same time. So there should be cost from the learning perspective, and there should be cost from running perspective as well, which at the end of the day will translate into business cost, money basically. And for short term, I guess for short term, it will be only the learning curve to get up and running.
Okay, I think we're down to the last question, sir. It's observability is leading to being biased in scope. What variable could we add to have a higher accuracy?
Well, we humans are biased by ourselves against different things, and observability is not an exception here. What I would recommend is to build a continuous improvement culture where you look around and dive into the problems when you see this, and try to also teach people that things can get that people can get biased, and understand and control those biases. So to be aware of biases, to be able to achieve and higher accuracy.
Perfect. So everybody, let's give a huge round of applause. Thank you, Vahe, for your precious time spending with us and sharing with us your expertise. Could you also grace us with a selfie with everybody? Once again, we're going to invite you to maybe stay right there in the middle. Just be careful, and we're going to call our photographers. And once again, everyone, if you learned a lot from Vahe's presentation, please put a big smile. Thank you very much.
Thanks, everyone.
Perfect. So don't forget to visit also Webb Fontaine booth outside later on if you haven't. And now, just like that, we are on our last session. Can you believe it? This is a very interesting topic because it is all about financial inclusion. I was actually shocked to learn that 7 out of 10 Filipinos are unbanked, which means they don't have access to formal financial services, right?